Alrighty, we're moving on to new stuff, which is very exciting. Let me go, I'll make sure I add the Zybooks chapter here. So we finished up loops. We're going to start on functions here. So this chapter 6 will be due on 10/6. Let me go put that in here before I forget. Make sure you get your loops chapter in by tonight. Fire up Zybooks here, see how we did. Oops, no, Zybooks. My goodness. No, I want to edit the URL. All right, that's fine. I can do that myself. All right, so next chapter, chapter 6. It's next week. And make sure you don't turn anything in. I had one of them set for like an online submission, and that got really weird. All right. Not so good with chapter 5. That's okay. We still have today. Right, only 36% of the way there. It's all right. It's not the end of the world, but and no one read ahead on functions. That's so sad. It's so sad. I make a whole lot more sense if you read the book, but it's okay. We'll make it work. So we're going to talk about functions today. Very exciting. So let me pull up PyCharm here. Did I not? I installed the new one, didn't I? I swear I installed the new one. PyCharm. No, I didn't. I really thought I have the new one installed because I had to go deactivate the license on it. Did I not? Hmm? I did the IDEA one, or IntelliJ one, but I thought I did PyCharm too. I had to go through and test something on the new version. Did I not? Okay, I don't see it on my list here. I don't know. That's weird. Forgot. We have a pre-test. I'm so excited to tell you we have a pre-test. Um, very exciting stuff. All right, I got that out of my email. That was not embarrassing. Here's our pre-test. And I can do that while PyCharm installs. That's perfect. This timing is perfect here. So, 4 questions. No, not that one. This one here. Yes. I do want, not any of those. Pretest. Email, browser. Oh, that did not format right. That's fun. Enable editing? No. My dark mode is unhappy with the picture here. I guess we can go back to, is it? I don't remember where you set it to dark mode. Under references? Switch modes. Thank you. It was there. Okay, I thought it was under view. There we go. So I'll add this to Canvas for you. Take this, fill it out at some point here. Don't feel the need to print and write on it. Just type in it. It's perfectly fine. I'm okay with that. It's just a quick little pretest check for us to see where everyone is ahead of time. And I can go off of the evil light mode because that's way too bright. Canvas is the worst too. And I can even give you a point for doing it here. Check it out. Let's go add our pretest up here. Go to assignment. Do you want a project point for doing it? I'll give you a project point for doing it. Why not? So at some point before the class is over, like how about December 3rd? Is that okay? Just go and give me that one there. So this one you can upload the pretest back there. Link to a file, to a force file, to a force file, to the pretest. Okay. So at some point, please take a minute, do that one for me here. And you get the point just for turning it in. You don't get a point or not a point if they're right or wrong. All you got to do is turn it in for me, okay? So it's okay one way or the other. All right, now we can do new stuff, maybe. Is it still installing? It's still installing. So slow. The bar's moving faster now that we're watching it. close my email too. There we go. I don't need to see all that garbage. Is this week 6 if we count first Wednesday as a week? I think it's week 6, right? It's 1, 2, 3, 4, 5, 6. We're 6 already. We are cruising our way through the content here, which is awesome. So after this, 1, 2, 3, 4, 5, 6, 7 more weeks of content. So we're almost halfway in terms of content, believe it or not, after this week here, which is pretty cool. So it's progress bar lies. You can just use the old pie chart. This is going too slow. It's making me sad. Thought it was going to be quicker. All right, so we're going to talk about functions. Now, we've actually been using functions this whole time. We just never really put a name to it here. So it's week 6. Functions. Excuse me. But now we're going to be able to write our own functions, which is a lot of fun. So there's a couple big benefits to writing functions. Now, the sad truth is, though, being able to write functions isn't going to let us do anything that we couldn't previously. We could still get the exact same thing done without functions that we can get done with functions, but we get a lot of benefits. So the first one is we get to put a name to some chunk of code. Like, this is what this chunk of code is doing, and put a name to it, which is great. Another one, obviously, is a good benefit, is we get less repeated code. Because anytime you have the same code twice, we should feel bad about ourselves. That's our good rule of thumb. So being able to have a function allows us to have less repeated code, right? And then the third one is my favorite technical term. It allows us to do functional decomposition, which is just an amazing buzzword. Go throw that out the next time you're out with a group of friends. They'll all know you're a nerd. Although if you want to be data scientists, they probably know you're a nerd anyway. But that's all about taking a big problem and breaking it down into a smaller problem. I can move this. Sorry, it feels like it's in the way. It's hard to solve big problems. It just is, especially with code, because it's hard to even know where to start when we come to a big problem. So if we can take a big problem and we can functionally decompose it into a smaller and smaller and smaller and smaller problem, it's easy to solve the small ones, right? So that's what we're going to do when we actually do the project. You don't have to use functions for the project. I'm going to use functions for a project because I think it's fun. Again, that's okay. It's not the end of the world one way or the other. But essentially, a big problem broken down into small ones here. And we want to be able to solve small things because that's easy enough to do, right? So if we want something like, we've been asking users over and over and over to enter values, right? Like, I think when we did our silly things, like, here's a list of good choices you can pick. Please give me one of those, right? We can make a function for that because it's the exact same thing every time. The only thing that's different is the list of valid options, right? So we can make a function. So we use the def keyword to define a function here. So this is, why no Python interpreter? Sure, use that one. That's weird. We're going to define our function. We're going to call this one get input, or what? Get valid input. Okay, and then a set of parentheses. Inside the parentheses, we're going to list out what you need to give this function in order for it to run. So to give it the list of valid options, right? So here's my valid options. And then I use a colon, right? Everything hangs off of that colon now as part of this function. Just like in our loop, everything hung off that colon. An if statement, everything hung off that colon. Everything inside of here hangs off the colon here. So we can get some sort of choice then, is an input of enter a, I don't know, choice here. And maybe as a formatted string here, we'll throw out the valid options, right? Again, we can make this look prettier later. We can go. And then we're going to say, while my choice is not in the valid options, keep on repeating, right? Just tell them, I don't know, maybe we just print out invalid entry. Please try again, dummy. And eventually, we'll get to where this loop should stop. Ideally, they give me the right answer here. And what we need to do now is we need to give that back to the person who called my function. So we have another special keyword. It's called return. It says give this back. We're going to return the choice. Okay. So what we can do then is we can have a list of options or choices here. Right? My choices then is a list, or maybe a tuple, right? It's immutable here. Of imagine we're gonna go to a corn maze. You can go up, you can go down, you can go left, you can go right, right? And we're stuck in some sort of corn maze here, and we're gonna have them navigate around it here. So there's my choices here, and then we'll ask the user to enter something. So we'll print. Um, I guess we can just get our direction then. Direction is get valid input given my choices. And then, hey, if my direction is equal to up, I'll do something else here, right? Right, you go up. If my direction is down, or I don't know, down, right? You go down. Very exciting stuff, right? You go down, and so on. We could do other sorts of things here, but then our menu, right? This is your list of possible choices here, is a function. We put a name to it, and then I don't have to have this code more than once, right? I can reuse this one here. And really, this sort of getting from a list of valid input we've done in almost every project already now, right? Now we have a nice little function that we can copy paste and reuse here and have reusable code, which is fantastic. So that's the big dream here is our code is good enough that we can reuse it, and maybe even other people would want to reuse it. That's why we have these libraries of code that some fine smart people wrote for us that we get to use. Right? I don't need to figure out how to take the square root of a number. Someone wrote a square root function. Right? We've done that already. Right? We did square root, right? Didn't we? It was a math.square root, math.square root, right? Someone else found out how to figure out how to make a computer do a square root. I don't actually know how that works. I don't know what they do behind the scenes here, but it works, right? Which is fun. So we get to use that. So building out functions allows us to build out this sort of library of code here. So enter a choice, up, down, left, or right. What do you want to try? Sideways? Invalid entry. Try again then. What should we try? Someone say left, and look, it finishes. It wasn't an option. We never finished out the rest of our program here. But so we've got a function then. Oh, it imported math for me automatically. Wasn't that fun? That goes and does something, right? And it returns an option. So this is a value returning function. Not all functions have to return stuff. You can write functions that just go and print something here, right? We can have a, I don't know, we'll call this Happy Monday. And you don't even need any arguments either. You don't have to give it anything, but you need to have the parentheses here. And all this one can do is print Happy Monday, print is it Friday yet? Right? And now I can call my function by name. I say Happy Monday and it's a parentheses, and it'll run that code. We get Happy Monday is it Friday yet? There's no returns, it just does something, right? So there's implicitly a return here that ends the function, but it's technically returning a nothing. Um, Weird stuff happens, like if you want, hey, my value equals Happy Monday, and they were to print value, and it's even telling you, hey, it doesn't return anything. You shouldn't be doing this here. But we get back this fun none. None is a fun keyword in Python, means nothing. It's null, it's empty. You don't have a value here. It's actually like a special keyword, which is fun. With a capital N, even here. So functions that don't return things, you don't want to assign here. And thankfully, PyCharm's like, hey, you did it wrong here, but Python lets you do it anyway. And it's like, oh, sure, you want nothing back? You have nothing. Go for it. So we can make functions that just do code. And that's okay too, right? We're putting a name to what this code is doing here. That's a nice benefit here. I'm sorry? Yeah. So our PyCharm is telling you you're using it this many times. You can click on it, and it will show you all the different places it's being used. So we've got some fun shortcuts in PyCharm as well for what it's how it's detecting all of that. Other things we can do with functions, right? You can have more than one argument passed in. So in here, so technically this is a parameter. When you define a function, you give it a parameter list. When you call the function, you give it an argument that satisfies that parameter. Most people don't care about the difference here. Just everyone calls them arguments, but sometimes you might see the word parameter around because some people like to do things. Now, I don't know if you noticed here, we've been using functions like print. Print is a function, right? It's got a set of parentheses. You give it something, and print does its job. Right? Print doesn't return anything, it prints something out on the screen, right? When we did int of an input, enter a number, some number, right? Int is a function. Int is given some string input and turns it into an integer, right? Input is a function that gives you back a value. You tell it what you want it to say, right? So we've been using functions before, but now we're going to write our own because they're much more fun to do it on your own. Now, the problem we run into is when we return values, you can only return one thing, right? You can't return more than one thing. Now, Python lets us cheat here because you guys know that a list or a tuple is one thing. It just happens to be a container that holds a bunch of other things. So you can return a tuple, which is one thing, but it has a bunch of other things, and that satisfies the rule. So you're allowed to return a container here and have more than one option, or more than one value here inside that container. So, and because Python knows we can do that, it lets us do it implicitly, which is fun. So if we wanted to have, I don't know, we'll define get two numbers here. And I don't know, we'll say within range. Within range. So you give me a low and a high. And we'll get some random numbers. So let's go import random. So we're going to get first number is random.nextInt, randint, sorry, low and high, and a second number, random.randint, low and high, and I can return first number, comma, second number. So what this is doing for me, it's implicitly giving me return tuple of first number, second number. Here, I don't have to add the parentheses because it's nice and helpful here. And it's like, oh, you want to return two things? You get that as a tuple. So to use that, remember, we've done a few of these things here. When we were looping over dictionaries, we did silly stuff like that. We said, um, here's my names or grades or something. It was a dictionary of Eric and A. Sure. We could say for name and grade in grades dot values. No, not values. Grades dot items here. Remember, we did this like comma separating because items was going to give us key value pairs here. We're getting two things out from items every time. So when we write a function that returns two things, we do that exact same thing here. So we can have two numbers here. The first number, I don't know, 1 and 2 is get two numbers within range of 1 and 100. Right? We just comma separate. Just like we did here. It doesn't have to be in a loop though, right? You just say, hey, I want two values here because I'm going to get two things out. That is a Python shortcut, right? So the slow way of doing it, we say the result is get two numbers within range of 1 and 100, and then my first is result index of 0. And remember, result is going to be a tuple, and then second is result index of 1, because result is a tuple. It's ugly, but this is the common shortcut. People who do a lot of Python will do this more often here. If you're getting two values out, you just comma separate them here, and Python will give you both of those values. We'll match them here. Right? It really is a tuple here, and then you can go get them individually by index from the tuple, or Python will just unpack it for you. The technical term there is unpacking. So it's an automatic unpacking of a tuple, right? And it's automatically packs your tuple here, right? It will pack it into a tuple when you just comma separate. You don't need to tell it, hey, I really want this to be a tuple, because it just knows. So Python has some fun shortcuts here like that. So we can have multiple values returned, one value returned, no values returned. Totally up to us here. So other fun things we can do with functions, right? We can do math. Everybody loves math, right? You all remember your quadratic equation of finding intercepts? I just did it in my earlier class, so it's fresh in my head here. And thankfully, because it took a minute to get it in my head here, and they laughed at me for being bad at math. So that's okay. You don't have to be good at math. You want to be at least decent at math for data science, but good at math might be a stretch. So anyway, we'll say get intercepts here. So you need an A, a B, and a C, right, to be able to get the intercepts here. Right? That's the form of ax squared plus bx plus c equals 0, right? That's our quadratic formula. So the first thing we have to do is see, do we even have any intercepts at all? Because I can't take the square root of a negative number, right? So I need to check first. So we can check, hey, that was the determinant, determinant, I don't know, that's probably close here, right, was b squared minus 4ac, so b squared, or b times b, right, whatever option you want, minus 4 times a times c, right? Before we take the square root of that, we need to see if that's positive. So if the determinant is less than 0, right away we know there's no intercepts. So we can return no intercepts, which is kind of weird. We can return a string, but sure, why not? If we didn't return a string, we can keep on going. So the return keyword will end your function as soon as it hits it. It doesn't have to happen at the end here. You can put one in the middle. It's a little bit awkward, but that's okay. And this is our first check here. If that's good, then our first intercept is going to equal negative b plus the square root of, so math.square root of the determinant. I have to go import math, yes. Please import math. Import math. So we already did it automatically last time. And then all of this divided by 2a, right? So divided by 2 times a. Someone should be yelling at me for being stupid. Thank you. Yes, thank you. Thank you. Yes. Very easy to typo that, right? Yeah, definitely. Multiply a first, then divide. And then my second intercept is the same thing, but minus negative b minus the square root of the determinant divided by 2a. Oh, but all of that, right? I forgot even more parentheses, friends, right? We would have had bad answers here, right? Because the whole thing is divided by 2a, or both of them, we can divide them both by 2a, or do the arithmetic first, because math is fun like that, right? And then when we're done, we could return the first intercept and the second intercept. Now these could be the same number, right? If you're determined at 0, you get the same number. There's just one intercept, that's fine. Sometimes we get 2, or maybe there's no intercepts. Now what's weird though is either we're going to return a string or a tuple. It's a little awkward for someone using our function here, right? Probably not very helpful for someone else to either get a string back or this here, but that's okay, right? We got lots of choices. Let's try it. So let's go. Now I don't think there's a valid range for numbers here, right? I think we can use any number for those. So I don't think we need to use our loop here. We'll have a as an input, enter your a value, and that's probably a double or a float, right? Because these can be numbers of decimal places for these formulas. We'll do a, b, and c. Enter your b value, enter your c value, a, b, and c. And then maybe we just print out the get intercepts of a, b, and c. So if we're just printing it out, if they give me a string, I print it out. If I get 2 intercepts, I print out 2 intercepts. That's probably pretty close. Again, we can come up with nice ways to do it here. Should we try it? Oh goodness. What did I do here? Oh, my for block. I forgot to finish some code examples here. Print name and grade. Let's try that. All right. What's our a value? 5. All right, what's our b value? 3. And what's our c value? 1.2. 1.2. No intercepts. I think you usually want like a negative c value to make sure we have intercepts, right? Let's try it again. 7. Negative 4. Negative 10. All right, we got 2 intercepts here, it looks like. I don't actually know if that's right or not. Do you? We should check it out. So you use Desmos for graphing things. I'm fond of that. So what values do we use here? I don't even remember. 7, negative 4, and negative 10. So 7x squared minus 10x, was it 10? 4. I really just wrote that down. Minus 10. All right, intercept at negative 0.94319. Look at that, we're more accurate than Desmos. We're winning. And the other one, 1.51 something. 1.51 something. I think we're pretty good. Feel like we got that one right. Awesome. All right. And again, we're just printing out the results. If we wanted to use it in some sort of arithmetic, we're going to be in trouble if we give back a string value of no intercepts, but that we can solve that problem later or do something with it later. Not super important to fix that today. All right. So we can write fun functions that do our own math stuff, right? We can add to the math library. Wouldn't that be really fun? uh, Now, it's upset that I have A, B, and C, and these little messages here, they say shadows name A from outer scope. It sounds really funny, but remember when we define variables, that's setting the scope of the values here. Now, if I wanted to do silly things in here and like change the values of A, B, and C after I've done all my arithmetic, A equals 0, B equals 0, C equals 0, I can go change the values all I want here. But when I come back here and print A, B, C, enter our values, what do we have? 7, -4, -10. My A, B, and C didn't change, right? The variables within the function are scoped to the function. So when I go and set them here, it's saying, oh, I never used the value. That's fine. I never used the local value. We changed it, but never did anything with it here. But I changed the copy of it, right? Changes it inside the function, but not outside the function. Because what I passed it was a copy of my value. So when we call our function, then we pass things, we're passing copies. This gets awkward. It's going to take a while for us to practice with it here. But I'm giving you a copy of this value here for my integers here. Right? Now, if I give you a list, though, you're not getting a copy of the list. You're getting, so our technical term for this is we're passing by value. So this is passed by value. We're giving the value of the variable here. So the value of an integer or a floating point number is the number, right? But if I were to pass you a list here, so let's have a list fun, given some list. And then we can say for index, I'm sorry, index in range, the length of the list, some list. I can go through some list at index of the index, right, and assign it by some list at the index dot upper. Right, we want to uppercase whatever's there. Assign it back to what was here. So if you give me a list, I'm going to go get the index, right, starting at index 0, index 1, 2, whatever's in here, and I'm going to go try and uppercase whatever's there. Okay? So if we make a list, then my list here, apples and bananas and cucumbers, that's probably fine. And I do my list fun given my list here. So if we print our list beforehand, print my list, we call our function, and then we print our list afterwards. If we pass by value, what is the value of a list variable in Python? You remember? What's actually stored by this variable here? Where the list is in memory. Right? The value of the variable name is just, here's where it is in memory. So the value of it's a memory address. If you give me the memory address of a list in Python, I can go mess with the list. Right? I can go add stuff to it here, right? Where's my list fun? After we do that, let's go and take some list, append, there it was here. Okay, so when I run my program now, I gave it this list, but because I'm passing the value of it here, it has the memory address. If you have the memory address of a list, you don't have a copy of it. You're actually modifying these values right here. So you can go change it, you can add to it, you can subtract from it, all sorts of fun things with it here. So you want to be careful when you're passing lists here. Careful of passing lists by value, address where it is in memory. Okay, because they can go modify it. Sometimes you want that, sometimes you don't. Sort of just depends here. Right? There's a how you want to go about that. So if you want someone to have a copy of your list here, when you pass my list, you can do this slicing. Do we do slicing yet? I didn't get to slicing. Okay, we'll get to it eventually. You put a colon here, and it gives you a copy. We'll come back to that then. So this is a pass as a copy. This will make more sense later then here with that version rather than this one here. But for now, when you pass a list, they're going to have access to it. Okay, so you just want to be a little bit careful. But sometimes that's helpful. Right. So with my like valid options here, I'd be able to change it. If you gave me a tuple, I can't change it. If you gave me a list, I could go change it. Right. So it's another reason tuples are nice. Right. If you know something's not going to change here, um, it's nice to make it a tuple. Right, if you don't want it to be changed, because then they can't change it there. So we got some options with tuples. Let's see, how are we doing here on functions? Printing functions. Oh yeah, just boring. We did prints, right? Our little happy Monday and Tuesday, or happy Monday to Friday yet. Other fun things we can do with printing, right? We do our shapes, we did triangles and things. We can have a function for print triangle. That might take, I don't know, the size and the character. So you can tell me more than one thing. We can comma separate. If you want more than one argument, just comma separate them. Right? Like we did here, you just comma separate. So we'll say for row in range, the size. Okay, so for every row, I want to now print this number of characters here, right? And really, I want to start at like 1 and go to size plus 1. This will make my life a little bit easier here. So I'll go from 1 up to including size rather than 0 to size. I can now print row, which is a numeric value, times the character. Remember, Python lets you multiply strings by numbers, because that makes a whole lot of sense. It'll just repeat it 1 time, and then 2 times, and then 3 times, and then 4 times, and 5 times, on and on and on. I don't have to have another loop inside. I think we did another loop for fun, just because we were practicing loops within loops, but we should be able to print a triangle this way here. So I can say print triangle. We can do, I don't know, a size 10 with, how about the percent sign character? Or we could print a triangle of size 7 with, I don't know, the dot character. We can get some fun triangles out here, right? So we have the same code happening. The only thing that's different is the variables. Right? We could have done this without a print triangle function before by just making our own loops. But now we've had the same loop twice, essentially the same loop twice. The only thing that would have been different is what we're arranging on. Right? So something to look out for when we're writing code is if you have the same code except for a variable. You want a little light bulb to go off in your head, be like, oh, that could be a function, and I could save some code and not feel bad about myself, right? We don't want to have the same code twice. So we have the opportunity to reduce repeating code if it's similar code, just operating on different variables, right? If it's the same operation, hey, I'm going to do the same, get some valid input here. The only thing that's different is your valid options. Right? Why not use the function? Right? I don't need to make another list here and loop through that other list here and have other prompts and reinvent the wheel here. We've got the chance to use this new. Now, again, we didn't need any of these functions to do any of this stuff here. We could have done all of this stuff without functions here. But it's putting a nice name to what's happening. It's reducing the repeated code here. And the other cool thing that it does, eventually, ours is a little bit messy here, is you sort of get to clean up your main section of code. And ideally, you want lots of code to be in functions and not so much stuff to be in main. So if you think about when we first started talking about code and this idea of how do you plan through solving something, I think the book mentioned pseudocode. Did we spend any time talking about pseudocode? It's kind of like code. It's just the thought process of I do this step, and then I do this step, and then I do this step, and I do this step. So pseudocode is really good for helping us define functions, right? If we wanted to figure out some sort of, hey, let's play the game rock, paper, scissors, right? Well, the first step I have to do is get the user's choice, right? So get user's throw, right? Sure. And then I have to get the computer's throw, get random computer throw, right? And the next thing I would do is tell the player they win, one, lost, win, lose, or draw, determine win, loss, draw. Now, to do that, you probably need the user's throw, right? And the computer throw, something like that. It's sort of looking like code, but it's not really code yet. I guess it's codey enough here. And then we have something about like play again. in here? Something like that, right? So we could take this pretty quickly from here's the steps that I need to do to turn them into actual working functions here, right? So like while play again, and that could be a function call, and that will either get me a yes or a no, right? I've got some list of valid options here, right? Like play again is a get input from valid options, get valid input of a y or an n, right? We could do that, sure. While play again, get the user's throw, determine win, loss, or draw. So then user's throw is my get user's throw, computer throw, computer. Oh my goodness, computer throw is a get random throw, computer throw, and determine win, loss, or draw of those. Sure, we can go write those functions. Right, so define play again. Now a function can call a function. Right, all this is going to do is return a get valid input given a y or an n. Now that's not great here, right? If that's the only thing I have for get valid input. I never gave them a prompt here, like enter a choice. Yeah, that's not great, but it's probably okay here, right? So, and that should be a tuple, right, of y or n. Nope, sorry, y, comma, and two different quoted strings there. There we go. That's just yes or no, right? To get the user's throw then, define get user's throw, right? This is, again, just going to return a get valid input of rock, paper, scissors. Rock, paper, scissors. Sure, right? Again, using the same function again here, that's fine. Oh, we don't need, I'll play again equal to y. There we go. I should do that right. Okay. Now, getting a random throw then, define get random computer throw. Well, it needs a random number, right? So we'll have a, I don't know, number or random, I don't know, computer throw. Doesn't, I guess, doesn't matter. Random.randint, 1 to 3. If it's a 1, if my computer throw equals 1, return rock. If my computer throw equals 2, return paper. Now, notice I don't need an else here, right? Because if you hit a return, your function's done. So we saved 2 letters. Yay, 2 letters off. And then if it's not a 1 or a 2, it's got to be scissors, right? I don't even need to check another one because I know it's just 1, 2, or 3 here. Being a little bit lazy, but we're saving some lines of code here. And then determine win, loss, or draw. It's the last bit we have to do here. We're going to define a determine win, loss, or draw. Here, actually, I can just copy paste that. Oh, goodness. Colon. So if the user's throw matches the computer throw, you can print tie, draw, right? Now the next one is a little bit trickier, right? And this is, I'm sorry, not print, return, draw. So this should probably print that, print determine win, loss, or draw. Right? If it's not that, then if my user's throw is rock and the computer throw is scissors, right? That one, or my user's throw is paper and the computer's throw is rock. If you don't do them in the right order, you need your backslash. Remember what the correct order is. My user's throw is scissors, and the computer throw. This is very exciting, right? Do we do a rock, paper, scissors already? Okay, good, good. Paper. Return, you win. Otherwise, we return, you lose. Right? That's our rock, paper, scissors, right? With functional decomposition. Right? If we wanted to look at someone's code, we could see this here and pretty quickly get a feel for what's happening, right? Because we put a name to all these things here. Put a name to all these things, right? Again, it's not perfect, but it probably is going to get the job done here. And then if you want to know specifically what's happening in each of the functions, you just go look at the functions. And you'd be like, oh, okay, I know what's happening here, I know what's happening here, I know what's happening here. So having a nice, clean little bit of code in main here is really nice. And we want the functions to do everything else. We're just breaking it down here. And then let's just stay focused on writing just small little functions. Take a big problem, break it down into steps. And we can always change our steps too, right? We're not locked in just because we decided I want to use these steps when I started here. We can always go change it, right? But if you think about the project we're working on, it's got a couple steps, right? Again, I'm going to solve it with functions. You don't have to solve it with functions, but when I go do it, it will, right? Like you have to go get their choice. You have to go get random numbers, right? You have to get their valid option here for return, those sorts of things. Self-destruct could be another function, right? Try again. We got lots of ways we can go about it here of doing these things, right? Setting values, changing values, having fun with functions. All right, let's see. Um, Now, one downside with Python is our dynamic typing here. You don't really get to tell the user what to give you here. So when I say, here's my function, and I want a print triangle with size and character here, right? Print triangle with size and character, they could also give me 10 here. 10, 20, 30, 40, 100. Oh, huh, that's not a triangle. It's not great here. So thankfully, in Python 3, which as far as I can tell, everyone uses nowadays. Python 2 has been old and for a long time. You might run into Python 2 occasionally, but we're pretty good on moving on to Python 3. You can suggest types. So you can say, hey, when I want a size, I want that colon as an integer. And when I want a character, I want that as a string. There are type suggestions here. So now when I go and use it here, and I try and give it a 10, it's like expected type string got int instead. It still lets me run it here, but at least now we get a warning when I'm trying to use the function that, hey, you probably should have given it a string here. Right? This one's not crashing, thankfully, but other ones might crash if we give it weird stuff like forget valid options. That one would crash if we give it something that's not a list here. So hey, we want this one to be a tuple. Uh, tuple. So get valid options then. If we were to try that with something else, try it with get valid input given my list here. We get a warning. Expected tuple got list. Right? And we can even say, oh, hey, here a tuple of type string. Isn't that cool? So tuple of type string. So
We use if you're working with someone else on a project, since you kind of already know what you would want when you're
so
typing the code.
it's helpful even for yourself,
This is like a reminder.
just to make sure you don't do the wrong thing later. Yeah. For now, like when your projects are 100 lines of code, you probably aren't going to forget. When your projects are 5,000 lines of code, the chances of forgetting are much higher. So yeah, being able to add these hints in is super helpful because then you get that little checking when we're writing it. Again, you can do weird stuff here, and that's perfectly fine, but it's just going to suggest, hey, you probably should give it something else, right? Really, a list is fine in place of a tuple. For our purposes, that's okay, but for us, it's just nice to have here. So, and we can go add all those in here. That's an int here, and that's an int here, uh, right? It's just nice, and these would be floats, right?
No way, they're almost like comments, but not annoying.
It allows the like Python interpreter to do the
Yeah.
checking for us, where a comment would just be like, please give me a string, and you're welcome to ignore it. Better, yeah, better comments. So it is considered code, so it's like self-documenting code, right? Because it's part of our code here, which is nice. So we can add those in. So that's helpful when you do your typing here. Functions, a function stub. This, as we're developing big programs here, I sort of wrote out, here's what this might look like, here's what this might look like. The stub says, I'm just going to make the functions here, and they're empty. You can use the keyword pass to just tell Python, yes, I really want this to be empty. Please let me run my program. Because otherwise, if you have it empty, you just say, hey, here's, define some function, and you leave it here, you can't run your program because it's like, oh no, it's missing something after your colon, right? Expected something. Oops, sorry, those were parentheses. But it's still expected something. So if you have the keyword pass in here, it says, oh, okay, that's perfectly fine. You'll probably come back here and finish this, right? So this is Python. It's okay to be empty, right? Just a little suggestion here for it, excuse me, it being empty or not. Yeah. So that way you can actually like run small bits of your program. So like rock, paper, scissors was quick, but if we're doing a bigger one, hey, I've got 15 different functions. I want to test my menu function first. I want to test this one first. I'm not even using the other ones yet, but eventually, we're going to do something with it here. Um, they're handy. All right, there was lots of common errors, variable scopes and functions, namespace and scope. We'll come back to these ones, I think, on Wednesday. I don't think we need to spend too much more time today because we want to leave some for Wednesday. There's more interesting pieces here. Um, and then, yeah, giving keyword arguments default. We'll come back to those ones. I think we probably got as far as we need to on functions today. We'll get through enough to get to the lab. We'll practice it ourselves. We'll come back on Wednesday, look at more of the advanced function pieces here with some of these other function arguments and keyword default parameters. Those are fun. Um, we did multiple outputs already. Arbitrary lists that one's awkward, but we'll practice it here. Now notice there's not a whole lot of Xylabs for this one. I know you're all really sad about that. Um, it's okay. We'll come back to more labs later. Um, yeah, so there's not too much when it comes to functions for the labs here, thankfully. Uh, just testing our program, which is really nice. So I don't usually get into testing until we get into classes. That's an easier level to test with. We'll get to that, but being able to test your function, we've done it by hand, make sure it's doing what it's supposed to do, that's great. So making sure it does what it needs to do. All right, we okay if we end a little bit early and then we'll meet up for lab at 2? All right, awesome. Sounds good. I'll go ahead and I'll get the lab posted for you and I'll see you at 2 o'clock. Have fun at Spirit Week or Homecoming Week. I've got some events down at the Chancellor's Pond. I think they're doing the boat races today. That's always fun. The cardboard boat races and miles of duct tape. Uh, Spirit Week, let me see, or Homecoming Week or something. Nope, you left the opponent. Homecoming Week. Yeah, starts Monday. Where's like the actual page here? Was it? I just skip past. I usually like ignore the first one now because it's almost always an ad. Yeah. Oh yeah. The races they go till 2 o'clock, so you can go check that out here. Um, it's fun to see people in cardboard boats with duct tape. I don't know. It's always entertaining. So that goes till 2 o'clock, just before lab starts. So, right. I'll see you around then.